Section 3.6, Zeros of Polynomial Functions. In this section, we'll use the factor theorem to solve a polynomial equation. We'll find the zeros of a polynomial function, and we'll solve real-world applications of polynomial functions. So the first thing we'll take a look at is the factor theorem. And the factor theorem says that k is a zero, or in other words, a root, of f of x, if and only if x minus k is a factor of f of x. For example, 2 and 3 are zeros of f of x equals x squared minus 5x plus 6 because x minus 2 and x minus 3 are factors of f of x. This is something that you've used probably ever since you've taken algebra. So whenever you want to solve a quadratic, like x squared minus 5x plus 6 equals 0, you know what you do is you factor. And then you set each factor equal to 0 and find the roots of the equation. Well, that's using the factor theorem. And the factor theorem says that k is a zero of the function if and only if x minus k is a factor. So since x minus 3 is a factor, 3 is a root. Since x minus 2 is a factor, 2 is a root. The factor theorem can be useful in finding roots of polynomials of degrees 3 or higher that are not written in factored form. If we had a polynomial that was written in factored form, for example, x minus 3 times x minus 4 times 2x minus 1 equals 0, if the polynomial is written in factored form and we want to find the roots, it's very easy to do. You just set each factor equal to 0 and solve. So for example, we would say the roots would be -3, 4, and 1/2. But what if the polynomial that we're given, the function that we're given, is not in factored form? Well, then the factor theorem can be useful. So let's take a look at this example. Find the roots of f of x is equal to x cubed minus 6x squared minus x plus 30, given that x plus 2 is a factor of f of x. All right, so let's get some room here, and we'll write down what we're going to do, and then we'll do this example. Okay. So the first thing we're going to do is we're going to divide by the given factor. And the reason we're going to divide by the given factor is so that we can find a quadratic equation that then we can go ahead and solve to find the other factors. So we want to take x cubed minus 6x squared minus x plus 30, and we want to divide it by the given factor x plus 2. And then this answer here is going to be a quadratic equation. And with that quadratic factor, we can solve it by using the quadratic formula or by continuing to factor. So we can either divide with long division or we could divide synthetically. Notice that x cubed, x squared, x, and a constant. Notice that all the powers of x are there, so it might be easier and faster if we use synthetic division. But you could also use long division if you would prefer. All right, so we will be multiplying and adding, multiplying and adding, multiplying and adding. Now, this 0 as a remainder is what we expected because we were told that x plus 2 is a factor. So since x plus 2 is a factor, when you divide, you should get a remainder of 0. So that's exactly what we expected. So we're pretty sure we divided correctly. So that means that we can factor f of x as x plus 2 as one of the factors, and these numbers help us create the other factor. It would be x plus 2 times x squared minus 8x plus 15. Now what we have is a quadratic. And we know that we can always use the quadratic formula to find the roots of this factor, or we might stop and before we use the quadratic formula, see if we can factor it. I think this one's pretty easy to factor. Factors of 15 that combine to give us -8. Let's take a look at x minus 5 times x minus 3. If we just do a quick check, -5x minus 3x is 8x, so yeah, that works out great. So now we have all of them as linear factors, we can find the roots. So the roots would be x is equal to, this is equal to 0 when x is -2, this is equal to 0 when x is 5, and this is equal to 0 when x is 3. Let's do another example just like that. Find the zeros if f of x is equal to x cubed plus 4x squared minus 4x minus 16, given that x minus 2 is a factor. So we're going to divide, and dividing is going to give us a linear factor times a quadratic. And then we're going to solve the quadratic. And you're going to solve the quadratic either by factoring, if you can, or by using the quadratic formula. All right, so here we go. Let's try synthetic division again. Notice x cubed, x squared, x, and a constant. So I don't have to add any zeros. All the values are present. So we have 1x cubed, 4x squared, -4x, and -16 for a constant. And the root of this factor is 2. Bring down the first number, multiply, add, multiply, add, multiply, add. And again, a nice check that we did it correctly was we were expecting a 0 for a remainder because we were told that x minus 2 is a factor. So these numbers here give me the coefficient of the quadratic, x squared plus 6x plus 8. And so far, we know that f of x then can be written as x minus 2 times x squared plus 6x plus 8. So here what we have is a linear factor and a quadratic. So all we have to do now is solve the quadratic. And again, we can see if it factors, but if not, we can always go to the formula. This one is going to factor as x plus 4 times x plus 2. And we could just check that, just to make sure. 4x and 2x is 6x, so yes, that factors that way. So now we can talk about what the roots are, because we have 1, 2, 3 factors, so we can write down the roots of each one. For x minus 2, we have a root of 2. X plus 4, the root is -4. X plus 2, the root is -2. So now we have the 3 roots, the 3 zeros of this cubic polynomial. What if we weren't given one of these zeros? What if it just said, find the zeros of this function, and we weren't given that f minus 2 is a factor? What if this was just missing? Then what would we do? That's a good question. If that were the case, I would definitely use technology to find the roots. There are ways around it. There are ways to predict what kinds of numbers could be possible roots, but really, those techniques are just never used. So if you were ever in this case where you had to solve a polynomial of a higher degree than 2, and you weren't given any help, you weren't given any roots at all, just go ahead and use technology, your calculator. So here, you try this one. So find the roots of f of x is equal to 2x cubed minus 9x squared plus 13x minus 6, given that x minus 1 is a factor. So let me help you get started. X cubed, x squared, x and a constant. Oh, so everything's there. So if you want to divide, you could do this synthetically and save yourself a little time. We would write down the coefficients. We would write down the root of this. So the root of that is 1. And now we're all set to go, bringing down the 2 and continuing on. Okay, so let's just go over how you got your answer and to check. So multiply, add, multiply, add, multiply, add. And again, we were expecting the 0. So this gives us the coordinates of the quadratic, 2x squared minus 7x plus 6. So this one now, so far we have x minus 1 times 2x squared minus 7x plus 6. This one takes a little much more work. I'm not sure it'll factor, but let's try. So we want to have 2 factors of 6, but we want the middle term to be 7. So if we try 3 and 2, oh, I think we've got it. That's 4 and 3. Oh, that'll give us 7. If we make them both negative, that'll give us negative 7. Oh, that'll do it. So we have x minus 1 times 2x minus 3 times x minus 2. So here we have our 1, 2, 3 factors, and you just make each of those equal to 0 and solve. So you would set up these 3 short equations and solve. 2 of them you can probably do in your head. One you might want to show your work just to be sure, but our roots would be 1, 3/2, and 2.